All right, very last section of chapter 3. We're going to put it all together, regression and correlation. Does it matter which variable is x and which one is y? Well, for correlation, no, it doesn't matter. You're going to end up with the same r value if you switched x and y. Not a problem. However, for a regression line, it does matter. Because remember, here's our slope equation. It's the standard deviation of y divided by x. So if we flip-flop these, our slope is going to change. It definitely matters which one you use for x and which one for y. So look at all four of these scatter plots. Which of the following has the highest correlation value? Can you tell? Kind of a trick question, because guess what? They all have an r value of 0.816 and a regression line of 3.0.5x. Interesting that they can have the same values but look so different. Well, here's the reason. R values do not tell us anything about form, remember? You always have to plot the data to see what kind of form we're dealing with. Just a reminder, how do outliers affect the following? Well, remember with correlation, if the outlier is in the pattern, then the R value will increase, will strengthen. But if it's outside the pattern, the R value decreases or weakens the correlation. It's usually by a lot. Now, what about a regression line? How does an outlier affect the regression line? Well, think about the seesaw that I showed you on the applet. What about standard deviation of the residuals? The further out the outlier is from the regression line, the larger your standard deviation is going to get. That's just the bottom line. Okay, a point is considered influential if removing it will markedly change the result of the calculations. All right, so here's the scatter plot showing the cost in dollars and the battery life in hours for a sample of netbooks, small laptop computers. What effect will removing the two netbooks that cost $500 have on the following? So let's think about this. If I take these out, this green line is calculated with these 2 points in it. What's going to happen though if I take these 2 points out and recalculate the following? Well, now this would be my new regression line. So let's think about it. How will our correlation value change? Well, the correlation will change from being weak, it's a weak correlation and in a negative direction, to being stronger and positive. What about the regression line? Well, it's going to change my slope from being negative to being positive and also decreasing my y-intercept because its pivot has gone so far up. What about the standard deviation of the residuals? Think about my residual values. If I took these out, I took out those big residuals, right? So it's going to decrease because the typical residual distance is smaller. And then lastly, r squared. Well, it's based on r, right? My r value got stronger, so my r squared value is going to be stronger since the correlation did. Here's a scatter plot showing the relationship between the number of fouls and the number of points scored for NBA players in the 2010-2011 season. So there's my scatter plot. There's fouls and the points scored. Describe the association. So this is a kickback to the very first section when we described scatter plots and we used DOFs, right? So the relationship of fouls and points scored is a strong, positive, linear relationship with no apparent outliers. So I have context, and I've covered all the DOFs: direction, outliers, form, and strength. B, should NBA players commit more fouls if they want to score more points? Is that what it takes? Well, is that what this is saying? No. The number of fouls does not cause the number of points. The association is probably because of playtime. Players who play more will probably get more fouls and more points eventually. It's just the nature of the beast. So you've got to be careful about questions like this, where it's implying causation, that fouls cause points. If you learn nothing else about correlation, it does not imply causation. You cannot reduce it to a cause and effect relationship just because there may be a correlation.